Alright, guys, continuing where we left off, we were naming alkenes. Okay, not kind of kinds. Alkane, alkene, alkynes. Always have to do that. We were naming alkynes. Um, so I'm going to do one more with you, and then we'll move on to what we're really focusing much on today. But for us to be able to do what we were focusing on today's lesson, we need to go over this part just a little bit more. Um, because today's lesson is going to be naming branches. Naming the chains are really easy, but naming the branches, that's where it gets a little tough. So, once again, I'm going to count how many carbons I have. 1, 2, 3, 4, 5, 6. I have 6 carbons. Let me write my C like a C. 6 carbons. So the prefix for 6 carbons, let me pull up my reference table again. The prefix for 6 is hex, like a hexagon, right? Right? It's hex. And because it has a triple bond, I'm going to end it with a Y and E. So hexine. Then, now that we have that, the Y makes an I sound, so hexine. Um, Now that we have the name for the branch, we just need to know, where is this triple bond? You said we have a triple bond based on the ending of the name, but where is it located? So once again, I'm going to just start counting from the side that is closest to that triple bond. Now, because it's right dab in the middle, it really doesn't matter which direction you start counting from. So for this instance, I'm going to start counting from my right to my left. So I have 1, 2, 3, 4, 5, and then 6. All right. So my triple bond is first attached to my third carbon. So the name is going to be 3-hexyne. And there we go. That's her name. All right. Same thing goes down here. It's basically the same thing. I just realized. So we're gonna go ahead and leave that off. But this is how you are naming alkanes, alkenes, and alkynes. Now let's move on to the branch. That's what I wanted us to focus on. So we did the chains. We learned how to do that. Go back and watch each example if you need assistance. But now we're going to be focusing on the branch, right? So the branch, not a straight continuous chain. It has smaller branches or smaller links or carbons reaching out from the longest chain. So first we need to find the parent chain. We need to name that parent chain. Then we need to locate the smaller branches. Now, to name the smaller branches, we're going to start like we did for the main chain. We're still going to we're still going to find out how many carbons it has. But now, instead of it ending with an A and E or E and E or Y and E, it's now going to end in a YL because it's not a chain, it's a branch. And then we're going to just find out what carbon it's located on and combine each step. So, what do I mean by that? Let's go ahead and let's do a couple of examples. All right, so here we are with our example, and we have our chain. So we see our main chain here. Let me get a pen out. We have our main chain here. It's the longest branch possible, but that we see. So I'm going to go ahead and name my longest chain that's known as my parent chain. So it has 1, 2, 3, 4, 5, 6, 7, 8, and 9. Not my best numbers, but viewable. 9. So that I have 9 carbons. Now that I have 9 carbons, right, I'm going to make sure I look at table P to find out what the prefix is. So the prefix for 9 on table P is known, right? Now, I need to finish the end of the name. So do I see a single, a triple, or a double bond? All looking through these, I only see single bonds. So that means I'm going to end in A N E. Now, I just want to make one comment. Do you see how it has these dash lines passing through it, but there's nothing attached to them? Now, if you don't see anything attached to them, it is always assumed that it's a hydrogen. So we don't want to spend all our times writing the hydrogen out, so we just do it without the hydrogen. It is always the assumption that if there's nothing else attached to it, it is just a hydrogen. Now, if the moment we have something else attached to it, we can no longer assume that it's a hydrogen, obviously. But if there's nothing else attached to it, that it's a hydrogen. So we have no name. That's the name of our parent. But now we see that we have a little carbon that's sticking out from the main line all by itself, right? So we have to name that. Now that carbon, how many carbons does that single little branch have? It only has one. So we're gonna name it, right? And because it only has one, the prefix for one on table, one carbon, the prefix for one for a table P is meth, right? So that's meth. Now, because it is not on the parent line, it's not on the longest line, and it's a branch that's stemming from the line, we're going to end the name with YL. So it's going to be a methyl, right? It's going to be a methyl. Real simple. Oh, right? But now I need to know, where is this methyl? Where is this methyl? So think about this. No name is the street. Methyl is the apartment building. We now need to know the apartment number. So we need to know the exact location of where the methyl branch is. Now, I started off my numbering from left to right. Now, if you must be consistent, meaning you must always be consistent with your numbering. You can't just change it. If there was something here and you counted from left to right, you need to continue with left to right. However, you're going to start counting from the side that is closest to the branch. We want to take less steps, right? So instead of you walking 5 blocks, you only want to walk 2 blocks. You want to start with the side that is closest to the branch and start numbering from that direction or that end. So I started numbering from left to right, and it actually is closest to the branch. And my branch is attached to my third carbon. So it's going to be location. I just like writing things out. Location is on my third carbon. So now let me put all these together. We're going to start with the number, the branch, and then the long name, the chain. So it's going to be 3 methyl known ane. And that is my name. This is where all the chemicals get their long names from. Alright, let's try another one. Alright, another simple one. There, they give us the condensed, and then this, they give us the structural. I always like using the structural because you can see it a whole lot easier than looking at the condensed. Or the molecular. Molecular really doesn't give you, the totality of it. So let's go ahead and let's identify our longest chain. It is here. Ooh, I tried. All right, and then let's start numbering it. Like I said, I like starting to number from the side that is closest to whatever I'm going to find later on. So because this side is closest to the chain, the branch, I'm going to go ahead and start numbering from this direction. If this was over here, I'll start numbering from there. So we have 1, 2, 3, 4, 5, 6. All right. We have 6 carbons. So 6 carbons. And I know that is a hex, like hexagon. Right? And then because I see only single bonds, all single bonds, I know that it ends in an ane. There we go. So hexane. Now let's go ahead and name our little branch that's over here by itself, that's sticking out. Right? So I only have 1 carbon once again. It's not always going to be 1 carbon. It might be 2 carbons, 3 carbons. Same thing, use table P, find the prefix, end it with a YL because it is a branch. So because I have 1 carbon, I know that it's a meth. And because it is a branch, not a chain, a full chain, I'm going to name it methyl. And I just need to know what carbon is my methyl on. And because I numbered it earlier, it makes it a little bit easier. So it is on carbon number 2. Location, I'm just going to say L2. So now I'm going to go ahead and write my full name. My full name is going to be 2, the apartment number, methyl, the apartment building, and hex aim, the street. And that's my name, 2-methyl-hexane. All right, let's try a few more of this, and this is exactly what you have on your notes for today. So thought I would doing your notes with you. All right, so A, we need to name the following. Once again, the chain. Here we go. Ooh. Let's do that again. Here's our chain, our longest chain, right? Longest chain, just count. If you need to include your branches into it and it's still the longest chain, just make sure your longest chain is something it has the longest amount of carbons. So 1, 2, 3, 4, 5. That's good. 1, 2, 3, 4, 5. Either way, if I go either way, I'm still gonna have 5, but I want a horizontal line. So I have 5 carbons. So I know I'm gonna write this here. 5 carbons give me pent. Now, do I have a double, single, triple bond? I have all single bonds. So it's going to end in an ane, so pentane. Once again, another piece of gas that's there, right? Now, I'm going to name, I see my branch is sticking out right here. Now, my branch has how many carbons? It has 2 carbons. So if I look on table P, 2 carbons is ethyl. Ethyl, good job. So ethyl, and then F, sorry. And because it's a branch, it's going to end in a YL. Right? Now, I need to know where is this ethyl branch on this pentane, right? So, because it's smack dab in the middle, you can go left or you can go right. Just in the case of this, I'm going to go right just so you can see what I'm talking about. So, 1, 2, 3, 4, 5. If I had started the other way, it still would have been on carbon 3. So, it really doesn't change much. So, location, it is on 3. All right, so now let's go ahead and put the names together. Location, branch, name. Like I said, I like to compare it to apartment number, apartment building, street, right? So 3 ethyl pentene. All right. All right. I'm going to leave B same as A. Now I kind of just wanted us to do the double just so you can see it's kind of the same thing. It's literally what we did in the beginning with you have to name your parent, right? But now the ending is no more ane, it's ene because now you have the double bond. So you have 1, 2, 3, 4, 5, 6, 7. That's hept, right? And then because it's a double bond, you have ene. And now you're going to do what you've been doing already. Your branch has 1 carbon. So that's 1 carbon, it's meth. Meth, and meth, because it's a branch, it's methyl. Now, you're asking yourself, am I going to start counting from the side that's closest to the branch or side closest to the bond? Always the bond outbeats the branch. So, the bond is on the first carbon, so it's 1 heptane, right? But the branch is on carbon number 3. So, it's going to be 3 methyl, 1 heptene. That 1 is telling me where the double bond is, the 3 is telling me where the branch is. And that's just what you're doing. Very simple. If you have any questions, let me know, and I'll see you in tutoring.